Around 10 million years ago, off the coast of what is now New Zealand, a spiny creature with long legs and sharp claws roamed the Pacific Ocean in search of food. This animal was an ancient ancestor of modern king crabs, known to scientists as Paralomis debodeorum. It carried a round, spiky shell and a body about the size of a baseball. But beyond those details, almost nothing else is known about it. The fossil that revealed its existence is the only specimen ever found. Based on how today's king crabs live, scientists believe that Paralomis likely inhabited very deep and cold waters. But whatever its daily life may have looked like, paleontologists agree that if you saw one alive, you would recognize it instantly as crab-like. Still, Paralomis was not a true crab. Instead, it belonged to an infraorder called Anomura, which includes a wide variety of crustaceans, from porcelain crabs to coconut crabs. And in fact, none of the animals in this group that we casually call crabs are true crabs at all. They evolved from crustaceans with long bodies and tails, more like shrimp or lobsters in appearance. For reasons still debated, many of these lineages independently shifted into crab-like forms over and over again across evolutionary history. In other words, they became imposters, false crabs. So why does this happen so frequently? What makes the crab's body plan so successful that even non-crabs keep adopting it? The answer seems to come down to one key trait: flexibility. Crab-like creatures first appeared in the late Devonian, about 365 million years ago, with the earliest decapods such as Palaeopalaemon. The name decapod comes from their 10 legs, and the order includes shrimp, crayfish, lobsters, and crabs, both true and false. Palaeopalaemon is the oldest lobster-like decapod ever discovered, and one of the oldest members of the order overall. It probably lived along the seafloor like modern lobsters do, and may have had specialized appendages for browsing through soft mud in search of food. By around 260 million years ago, decapods had split into two major groups: the Anomurans, or false crabs, and the Brachyurans, or true crabs. The oldest confirmed true crab is Eoprosopon, which lived about 185 million years ago in the early Jurassic. For a time, scientists debated whether it truly belonged within the crab family, because it retained some unusual traits, like a slightly elongated abdomen and very prominent antennae. But after re-examining the only known specimen with modern imaging technology, researchers concluded that Eoprosopon was indeed an early representative of the true crabs. On the other side of the family tree lies Platycota, which lived roughly 200 million years ago during the late Triassic. It is considered the oldest known false crab, and in form it resembled a lobster far more than a crab. Yet as time went on, both Anomurans and Brachyurans gradually evolved closer to the compact, rounded shape we recognize today as the crab form. This phenomenon has puzzled scientists for more than a century. One of the first to recognize it was the English zoologist Lancelot Alexander Borradaile, who in 1916 gave it a name: carcinization, literally, to evolve into a crab. He described how the long tail of a lobster gradually shortened and tucked underneath, while the carapace flattened and widened, eventually producing something that looked unmistakably crab-like. But why do animals keep repeating this process? In the 1980s, a study that examined fossil crustaceans throughout the Mesozoic era revealed a sudden explosion of crab-shaped forms. More recent work shows that this trend peaked during the Cretaceous period, a time paleontologists jokingly call the Cretaceous Crab Revolution, or the broader Mesozoic Decapod Revolution. Nearly 80% of the major groups of true crabs alive today trace their origins back to this evolutionary surge. Throughout the Mesozoic, diversity shifted toward crab-shaped species, particularly true crabs, while long-bodied lineages declined. These crab-like animals also occupied a wider range of habitats compared to their lobster-shaped relatives. One explanation is that their compact body form made them more mobile. A rounded, flattened shape allowed crabs to walk, swim, and burrow with greater efficiency. Some species could even climb trees, nightmarish as that sounds. By contrast, shrimp and lobster-shaped animals were generally limited to swimming, burrowing, or crawling along the seafloor. Another idea is that the crab form provided better defense. By losing their long tail, they eliminated an easy handle for predators to grab. All told, the crab shape offered real survival advantages, and natural selection favored it again and again, driving many long-bodied crustaceans to converge on a crab-like appearance, even if they were never true crabs. Yet, not every adaptation endures. To complicate the story, there have also been cases where crustaceans lost their crab-like form, a reversal known as decarcinization. One striking example is the fossil crab Palaeopalaemon perplexa, which lived about 95 to 90 million years ago during the so-called Crab Revolution of the Cretaceous. At first glance, it looked somewhat crab-like, but it was far from typical. It had oversized eyes that were not set on stalks, paddle-shaped front limbs, and a body unlike any modern crab. In the end, it all comes down to how well a creature can adapt to the challenges of its environment. Thank you for joining me for today's exploration. If you enjoyed this journey, don't forget to like and subscribe for more.